And as you can imagine, this is definitely important for square roots because a value times itself gives me a always gives me a positive value. But let's consider the case where we have x to the third equals, let's say, 8. Okay, well, you kind of start choosing some numbers. If x equals 1, then x to the third power, which is 1 times 1 times 1 times 1, would give me 1. Well, if x is equal to 2, we get 2 times 2 times 2 is equal to 8. So in this case, our solution would be x equals 2. Now, what about negative 2? Does that work here? Well, let's try it. So if x was negative 2, then that means negative 2 times negative 2 times negative 2 should give us the same answer. But negative 2 times negative 2 gives us positive 4 times negative 2 gives us negative 8. So it doesn't work whenever you don't have a pair of negative values to multiply together. Like the negative times a negative would give me a positive, but then you incorporate one more and you're back to a negative. So we could apply the same process, but whenever you're looking for what value times itself 3 times gives me 8, this is called the cube root. Okay, and so in this case, the way we would write it is, in order to solve for what x should be, we could take the cube root of both sides. So the way we do that is we still use the radical symbol, but in this case we're saying what number times itself 3 times gives me 8. And with square roots, just to kind of recap over here for a second, when we take the square root, we actually don't show, but there is a 2 here to indicate that it's the second root or the square root. And so we get these things to cancel out, and then our answer was plus or minus 2. Well, same type of idea. If I take a number and I cube it, and then I cube root it, I'll get the original number back. So to find this in my calculator, I would just do, to get the cube root button, I actually can't just do the square root button preceded by a 3. I have to press math, and then under the math option, there you see it right there. That's the cube root. Option 4, and the cube root of 8 is equal to 2. Now be careful, you can't just do 3 square root 8, because that's actually 3 times the square root of 8, which is totally different. So x would equal 2 in this situation. Now in a similar setting, if we look at x to the fourth equals, let's say, 20. So what number times itself 4 times gives me 20? Well, we could, in the similar fashion, take the fourth root of both sides. Okay, but in this setting, the question becomes whether the fourth root of 20 is just a positive value or also a negative. So the way to do the fourth root is actually put in a 4 first, go to math, and then option 5, actually it'll treat the number before the radical sign as the root number. So this would be the fourth root of 20 would give me 2.11. So that means that 2.11 to the fourth is equal to almost 20. Again, because of rounding error, we don't get the exact 20 back. But we can see that 2.11 is the correct answer. Okay, so what if we're trying to find roots that aren't perfect? For example, what if we wanted to do the 2.3 root of 7? So what would that mean exactly? Well, certainly we could take the 2.3 root of both sides. Kind of a weird thing to think about. What number times itself 2.3 times gives me 7. But I could do the same thing. 2.3, math, option 5, 7. Oops, I have an extra parenthesis here. Delete that. I get 2.33. So that means that if I take 2.33 for x, and I raise it to the 2.3 power, I should get, voila, about 7. Now, rather than to have to deal with all these radicals and so many symbols, let's think about one of the properties that we've already encountered. So I'm going to throw another problem out there. X to the 7th equals 15. So what number times itself 7 times gives me 15? Alright, well, we already know this property, that a value raised to a power raised to another power allows me to multiply. Well, rather than to take the 7th root of both sides,